Approximately 3 or 4 years ago, we were contacted by Lancaster University with a view to sponsoring either an MSc study or even a PhD. Well, it was a PhD which really caught our eye. And we were looking at trying to quantify the agricultural and agronomic benefit of recycling, specifically the bypass dusts which are produced from the cement industry back to agricultural land. We do benefit statements for each individual block of land, of course, get approvals from the Environment Agency, but we wanted a high-level study to quantify just how much potassium, the neutralising value, how that impacted on a whole range of crop performance, and Lancaster was really the place for it.
Julian Silverwood, who's the manager of Silverwoods Waste Management, came to the university. He had some good evidence from the farmers that his products were benefiting their crop growth, but he really wanted to get a scientific basis for why this might be the case.
When I was at Lancaster University, I was approached by Julian from Silverwoods talking about how these industrial waste, cement bypass dust, can be reutilized in agriculture, especially to supply nutrients and capture carbon dioxide. Julian was impressed by one of our papers published just before that, where we showed that mineral amendments can help remove carbon dioxide from atmosphere and grow more food. He asked whether this material can be used for the same purpose.
So EcoI Northwest is the group of people that broker these academic business collaborations, such as this project we've been discussing.
We've been working with 2 students, Rachel doing the first study and most recently Molly, both of which have been fantastic to work with, really enthusiastic.
So we are currently in a greenhouse here. This is where I have a current experiment being set up. This is called a column experiment, and I am growing ryegrass at the moment because it is simulating a field site that we do some field experiments on where we grow grass. These columns have been directly inserted into the ground and taken a profile of the soil, and we apply the cement bypass dust into these columns, and we look at the chemistry changes in the soil, in the leachates, the water running through it, so we collect that, and also the biomass as well. And we also look at some gas exchange between the soil, plants and the atmosphere. And overall we can use this and we can look at the data to see what sort of chemistry changes are happening, how quickly that the cement bypass dust can be used to sequester carbon.
I have to say that working with Lancaster University and Eco Innovation Northwest has been absolutely brilliant. It really has. It's given us a level of credibility, a much greater technical understanding, and it's really benefited the business, because I think what it's done, it's given us a level of credibility, not only with the farmers, but also with the regulator, with the Environment Agency who polices all our operations, that we are working at this sort of level within the industry. And of course our customers are very interested in that. All the cement industry, throughout the UK, we're dealing with each individual one of them. And finally, and by no means least, it's the farmers as well, that they've got that level of confidence that what we are supplying is going to do some good.